So our next speaker is Rohit Goswami. Rohit is a Ranis-funded doctoral researcher in the Johnson Group of the University of Iceland. He's currently working on quantum chemistry and data science. He is also a software engineer at QuantSight, working on Fortran projects. And he's been using TeX for over 10 years in various forms. And now we're going to show the video.
Hi, good morning. My name is Rohit Goswami, as seen on the screen, and I'm very happy to be here talking at the 42nd Tech Users Group meeting conference, right? And I'm going to be talking about continuous integration and tech with orgmode, or tech in the cloud. So, to start out with things, who am I? So, there's more information about me on my website. I am a doctoral researcher at the Johnson Group in the University of Iceland. I am part of the Faculty of Physical Sciences and the Science Institute there. So below at the lower left, there is funding. And on the right-hand side, there is school funding source and also the slide attribution, right? Okay, so moving quickly forward. What is the big picture which we're trying to solve with this talk? Or what am I trying to talk about today? Well, it's about tech, right? Tech is well known to be one of the best typesetting systems, and the problem really is that when we talk about collaborating with colleagues with regards to tech, then either we hope that our colleagues have some expertise with it already, we hope that they know how to work with Git, we hope that they know how to work with LaTeX diff. There are a lot of fantastic community tools, but there is a high barrier of entry, right? Or we use Overleaf. And Overleaf is great. They're one of our sponsors, and there are many talks from Overleaf here. So yeah, but here we're going to talk about an alternative, really. We're going to discuss alternative methods to doing this. Okay, now, the truth is everybody wants to see tech output without writing tech, right? I mean, many people would be very happy to get a presentation like this, which is made in Beamer, but they would probably prefer to make it in PowerPoint. And the truth is there are a couple of community tools which allow for writing LaTeX in a manner which sort of abstracts away tech, right? So there's Pandoc. There was a presentation on this last year. And this year, I'm going to talk a little bit about orgmode. And they basically promise tech and PDFs, nice, beautiful PDFs in different formats without the pain, right? They promise all the typesetting you want, but without learning an slightly arcane syntax, right? And also, the other thing which brings this about is the fact that nowadays build machines are so cheap. We can spin up cloud machines anytime we need, and even on public source repositories, right? And so the goals of this discussion is going to be how to generate a non-expert tech workflow which requires no proprietary tools and has a transparent Git and CI setup. And it's still going to be expert friendly in terms of templating. So what that means, we're going to talk about in a few seconds. Okay, so if you guys have been attending the fantastic introductory workshops which have been happening in the beginning before the conference, then you already know how to write LaTeX, right? Or tech. This is the most simple basic example you can do. And at this stage, it doesn't look bad at all. Like we start with the document class, we have an author, title, and this seems very nice, very eminently rational, I would say. And the truth is, any tech example I could show you on a slide, if it fits on a slide and it compiles, then it's going to be trivial enough to be easy to understand. And you might ask yourself, why would we want to go beyond this? But the truth is it quickly gets out of hand. Okay. And when it does, this is a well-known fact, when things do get out of hand, then we go towards like when we want to write a book in LaTeX typically, or if we want to sort of keep away all the typesetting and focus on writing, then we split our tech file up, right? And how do we split it up? Well, there are CLS files, class files, which can be loaded into document class, right? And there are style files. For example, Beamer themes are essentially .sty files with Beamer theme prepended to it. Okay. Now, additionally, if you are putting this in a repository somewhere, or if you have a lot of TeX files, then you probably want to move towards one of the build tools of TeX, either a specialized build tool like Arara or LaTeX Make, or if you're not into any of those, then you might want to write yourself a makefile or a Bazel tool or something like that, right? You need some sort of makefile, and whenever you have some sort of build system, you need some sort of control file for it. And CTAN, basically the Comprehensive TeX Archive Network, handles downloading all of these files for you, typically the well-known ones which are published on CTAN, right? And this basic concept is great for collaboration. It is sort of the bedrock of collaborating over TeX, which is to say that I can send someone, or they can send me a plain TeX file, and it can be typeset in a particular format pretty easily, right? Okay, so what if we want to move away from this? Well, the first two examples which we'll see is of orgmode and pandoc markdown. So there's orgmode on the left, and orgmode looks slightly similar to TeX, only with more white space, right? So we have a special syntax for author, title, and yeah. If you look at pandoc markdown, then typically if you want to add metadata, then you need to either supply a separate YAML file, or you need to pass it on the command line, which is what you can see in the code block on the lower right, which compiles the pandoc markdown above it, right? Both of these, by the way, on the left, the lower left shows the orgmode command, basically the lisp command which you'd be running inside Emacs. And this appears a lot more readable, a lot nicer, right? All of those things. But there's a catch. The catch is that this mechanism pollutes our outputs. And what I mean by outputs is whenever you do a generation of LaTeX, of anything really, there is some form of template substitution going on, and what that causes is the number of lines, the things which get added is a lot more. So these are variants of the same basic simple TeX file which we saw in the first slide, and that's called base.tex, and that has only 8 distinct lines. And as you can see, there's 15 in the orgmode generated one, and there's 63 in the pandoc generated one. Now, this is by no means a fair comparison because I'm using the default templates here for everything. I could have modified the pandoc template, in which case it would be much smaller, but we'll get to that. So there is some small trade-off which you do, which means that if I hand you a generated TeX file, then it is less interpretable than both the original file and a plain handwritten TeX file. Okay, this is a trade-off which we should keep in mind. Now, let's talk about substitutions for a few more minutes. And the pandoc approach, the bottom, the first one shows how a pandoc TeX template looks. You have these sort of directives which you can use, and these directives are substituted from the YAML metadata or from the command line options. And I love this system. I have a lot of projects that use this. One of them is called Zen Yoda, which creates a whole set of slides using Reveal.js, using Beamer, all of these things. And it's very nice, really, but it's kind of inflexible. The orgmode approach is slightly different. It's more of what I would call a bottom-up approach, because you define the structure of your document within the file itself. There's no separate template file which you need. And this is not strictly true because there are certain variables which are preloaded, but we don't need to talk about them right now. And so, yeah, there is this syntax. These are called, so you have these little directives which you put in your document, and these correspond more or less to the LaTeX commands which you might expect, right? Okay, so conceptually, the org exporter assumes only one output. Like this is specified for doing an org to LaTeX thing, which is why a lot of these directives have LaTeX in their name. And the good part is you can do arbitrary Lisp evaluations, and we'll see how this really provides us with a lot of power. Pandoc, on the other hand, as I mentioned, it is based around the sort of templating and template expansion thing, which is good and bad. It's good in the sense that if you want to publish a project, then you can just supply the pandoc template. And it's bad in the sense that it's difficult to sort of, I mean, you need to have a lot of things open. You need to keep track of a lot of moving parts. Okay. Okay. Quick one-slide intro to continuous integration. Nobody likes switching computers to test, right? There are too many operating systems nowadays, and there are too many continuous integration systems nowadays as well. Travis CI is cut out because of their horrible backstabbing behavior with open source projects. But yeah, GitHub Actions is there, and GitHub Actions is great. And the way these work, even though we're not really going to be talking about that, is that they spin up a virtual machine, either something based with Docker or something based with Nix, the newer, hipper ones, right? And none of that really matters when we're writing LaTeX. What does matter is if we all assume that some remote machine is going to run our build for us, then we have a single reproducible source of truth. No longer do I need to argue with my collaborator about which LaTeX version I'm using, he's using, she's using, you know, no more bickering, basically. Less bike shedding, more work done. Okay. And plus we get free tests. So if someone breaks the build, if someone breaks the documentation flow, then you know immediately. So the first thing is, how do you teach a remote machine about tech? You could use the package manager, but that's pretty fragile. My preferred method, and the one which we'll assume throughout this, is that you set up a simple TeX Live profile, right? One which basically uses all these local paths. The reason why they're local paths is so we can cache them. I won't talk about caching very much here. That's more of a CI thing. And then the fun thing is there is this wonderful package on CTAN called TeX Live on Fly, which is Python based. And what it does is it uses TLMGR to download packages as and when they are needed, right? I'm going to speed up a little bit. So the script for this, if you've ever installed TeX Live from source, then this is not going to look very surprising. The key thing to note here is on line 6, where you do the install using the profile. And after that, there are a couple of sort of basic packages. LuaTeX is really used just to add something to path because I wanted a command which I could test. Anyway, that's not important. The important thing is we turn off auto backups, line 18, because they're not required. And yeah, that's how you teach the CI to make tech. What this looks like, now the configuration files for different CIs look slightly different. There's small variants, but they all roughly look like this or are similar to this. Here in this presentation, I'm going to be giving GitHub Actions as the canonical example throughout. Okay. All right. So how much Lisp do we need to use org and LaTeX together? A lot? Not really. Just what's on the slide and a few more small concepts. The main thing to remember about Lisps, well, one of the main things is that you have these round brackets, and those define your scope, and you set variables with setQ, and you can define functions. So yeah, here we see on line 1, 2, and 3, we are requiring certain packages, and then we are setting the PDF process, basically what we're going to call if we were to generate a PDF. Actually, in most cases, I prefer to not generate the PDF inside Emacs or within the Lisp system, because if it breaks, then it's a lot more difficult to debug, but that's a different question. Okay, line 5 is special because it sets minted up as the backend for code highlighting. It's typically a good idea. It defaults to listings because listings, I believe, does not require Python. But especially if you're configuring a CI, then it is a good idea to use minted. And then there's certain minted options. Minted is a little special because these options are basically inserted before each code block, which is why they need to be set in a variable. And the last one, the one on line 8, essentially says, as soon as you save this file, export it to a TeX file, a corresponding TeX file. It is a Beamer export, which is very similar to the LaTeX export backend, but it's slightly different and picks up certain Beamer related headlines and these things. Not very important to know in great detail at the moment. So what is the minimum syntax going to look like? Well, this is an example right from this slide, actually. It's sort of dog fooding example. So what you need to know is that source blocks are enclosed within this begin source, and then you can provide the language. Everything else is optional, but typically, and yeah, they're denoted here, you can export either the code or nothing or the results. You can evaluate these snippets. We'll talk about why evaluation makes sense a little bit later, but yeah. And if if you just plan on writing a block of text, suppose you're writing with a custom math package, or you have a lot of LaTeX and you know it's going to be in LaTeX, then you can directly use begin export LaTeX, and then it will simply generate LaTeX in your LaTeX outputs. The very good thing about this is if you are planning to use orgmode for something for some other export as well, then you can also ignore certain types of exports. So that's just a bonus. Now, that's well and good if you're writing something from scratch, but most of us already have a lot of CLS files, a lot of STY files, and yeah, I mean, I had one for a report. And so what you want to do in this case, if there's an existing project, then you can sort of treat the orgmode file as a zip file. Okay, you can sort of insert the entire contents of the file and ask it to tangle to a file. Now, what does tangling to a file mean? In this scenario, it just means that it is going to copy the input of this block, the input of this source block, into this file. The eval always is to make sure that it is always going to overwrite this every single time, right? Okay. That's great, but there are some situations, many situations actually, where even that isn't good enough. There are times when you're going to be using standard packages, and that's about it. So in those situations, you don't really want to clutter your workspace. You don't want to generate a lot of STY files or CLS files. In those scenarios, if you're not writing TeX, when you do an export block, then by default, it goes inside your begin document. If you want to put something in the preamble, then you need to use the LaTeX header, this directive, as shown on the slide. That's pretty much it. But there's a lot of flexibility here. There's one last special thing which we'll talk about before wrapping this section up, and that is the fact that the LaTeX class directive is a little bit special. It is populated from a variable, okay? So because of this, you need to either add it in your config, but we're not going to be talking, so we're not talking about configs in this presentation because this is not about Emacs or org mode. This is about doing it in an automated manner. And when we say automated, then we're going to want it in a single file, which the CI will consume. And so what we're going to do is we're going to add this little bit of Lisp, and we're not going to export it, but we will evaluate it. And in this, on the slide, as you can see on line 3, I'm defining a new class called Tufte which is the Tufte style only in book form. And yeah, that is what we're going to be doing. So what about the much vaunted and promised replacement of Jupyter? How does that work? Well, so if you were working in this workflow, then it would look, you would type out code on the left. As you can see, you get full syntax highlighting. Org has this special thing which allows you to edit special blocks. And in those situations, you can even connect to a language server, which is very useful. So you can connect to, say, the Python language server so that you write your code almost in an IDE fashion, but then it also just runs in plain text. And so, okay, there are a couple of special things going on out here. If you look at the last few lines, okay, first look at the top line. So the property line basically is where you need to set the paths for the things that you're going to be running. In this particular case, I was using Python, so I had to set the Python interpreter. And then secondly, I also gave it a session. This is just a convenience because I often run a lot of sessions and then they can pollute their own, I mean, they can sort of pollute the same space, which is why I run each of them in a separate session. And this is another free fact which you get when you work in this thing, which is that it automatically saves only the code parts, only the source blocks into this separate Py3 file, which is great because if you're working with Jupyter and if you've ever exported something, then it's less than ideal. This is really neat. The caveat is when you want to display, when you're working in this workflow, if you want to view an image, then the image must already be written to disk. You can view an image inside org mode, but it has to be a disk image. So what you say, look at the begin source line. It says output file, and we're very clearly on the third to last line, fourth to last line, it says save figure. And that's why it's being able to be visualized. Okay, this is a good thing. It helps with the export as well. All right. So, and the PDF output, not only does it come without any special features and it looks a lot better, you get the full LaTeX customizability. You essentially, you get to do all your typesetting as though it was a pure LaTeX document, and then basically as though it's an augmented LaTeX document. And you still get to interactively work with your code, which I think is really fantastic. Okay, there's just one thing which I've been sort of sweeping under the rug, and it's the last topic I'll be covering, and that is, how do we tell the CI, it's all well and good, but Emacs is well known to be a way of life. What if you've not taken that step yet? Well, the truth is, you don't have to, and neither does your CI. This is the basics of the script which is required to export an org file to TeX. Essentially, the key thing here is that we are requiring a couple of packages in the first 11 lines. The 11th line is to include orgref, which handles bibliographies very nicely. So, and it's on Melpa, which is the sort of the CTAN equivalent for Lisp packages. And then we finally generate this, we define this function on line 15. And that's the main thing. When we call this function, when we call this on the command line, that's what I'm going to show on the next slide, then we can simply, so line 2 in the first code block executes this .el file, this Lisp thing, with this file name .org, and it's going to generate for us this file name .tex, which we can then compile on any given CI using the 4th line, TeX live on fly. It's fantastic, really. It's really nice. Okay, because of paucity of time, I would be very happy perhaps to maybe give a workshop on this later, sometime, some year. But here I omitted caching and working with Emacs, Lisp, and all of these advanced concepts. There is a slide on advanced concepts, but I'm running a little over time. And also about more, so orgmode allows more than just using one language. It's not Jupyter. It actually allows you to, if you felt like mixing C++ code and Fortran code and Python code all in one and passing variables throughout that, you can do that in orgmode and generate a beautiful looking PDF report as well. So yeah, I mean, there's one advanced concept here which is related to NoWeb. I see we have one talk in this conference on CWeb. So yeah, maybe something like this will come up there. And yeah, so the conclusion which I have, the conclusions are orgmode provides a viable alternative syntax for writing TeX, but it's more than that because it allows you to execute code snippets and sort of interactively generate beautiful reports, all the power of TeX plus whatever trappings of Jupyter you want. And you can also now link it very easily to the CI. There are examples of this. There are links in these slides. So feel free to go and check them out. And, TeX is here to stay. We're all here to stay. And abstracting complexity away from the users is good, but it's also very important that this workflow, okay, the reason why we want to use this is because of certain shortcomings in the overly free offering, which is to say it does not support branching. It does not support a standard Git workflow. There are ways to augment the CI workflow even more. You can run a bot on every pull request to generate a LaTeX diff PDF every time your contributors send you something, which is really fantastic. It's actually a trick I picked up from a collaborator of mine. And yeah, that's what I've got. And thank you so much. And thank you for your time. And I am happy to take questions.
Thank you very much, Rohit. You actually have got almost 20 minutes more if you want. I'll schedule 45 minutes for every talk and then the break begins.
Oh, my.
So,
I see. I was expecting 20 to 25 minutes. Oops. Okay. But that's okay because I did actually miss on a couple of things. I missed out on a couple of things which I probably should have shown. So yeah. So basically, the idea is that you have, every time you want to do this, then you have a configuration block, and that's where you set up the variables. And if you want, you can add a separate class here. So an example of adding a separate class is here. So in this particular use case, I needed to use a CLS file. So I needed to add it to the LaTeX class. So I do that here. And one parallel for this workflow is you can think about this as sort of a Jupyter notebook, but you also get to programmatically change what gets loaded later. And the nice thing about this is also that the renderings on GitHub become a lot nicer and a lot easier for people to read. So the slides for this, for example, show up in a pretty readable manner if you just dump the orgmode source. And this is good because it's kind of hard to read LaTeX on GitHub typically. And yeah, so I will take questions now if there are any, but yeah, I should have realized that before, sorry.
Yeah, I have repeated questions, of course, as usual. Concerning the CI, I mean, that is an interesting topic, and the way you mentioned or presented the CI, I think that is rather, it can lead to inconsistent results because you get new installations again and again. I mean, you mentioned caching, so it's not real, but you didn't go into details, which is not clear. The problem is if you install TeX every time anew, you might get into problems with new versions. So there are Docker images that bake into a TeX at a certain stage. It might be good to start from those, because where you really have a fixed, unchanging setup. And this is something that is very important for CI, because especially if you use newer packages or heavily developed packages, you will get into problems. The other option is you can, of course, install from a fixed date. I mean, there's the TLNet archive on my server, so that is used also for the Docker images, so that you get also a fixed set of packages that you know about to being installed. Otherwise, I think CI, reasonable CI, because I mean, if you write the paper, it takes months, and within months, lots of packages changes. So if you want really a good CI integration, then you want to have something fixed. That is the one thing I would say. I agree. I think the whole idea of having CI for TeX documents is a great idea. And I think there is a lot to do and a lot to improve how we provide services for continuous integration of TeX documents. That is something we could actually work on. Yes. Thanks again. It was a really nice talk.
Thank you. And yeah, it would be much better to actually pin to a particular version. What I was doing was setting up a cache, and then if the cache is already present, then it just doesn't re-download or look for new packages or anything. But of course, if someone changes or adds a package, then it will go in and try to update the entire thing. So it is more fragile, which is a very good point. Yeah. Yes, I also have an example I could probably show.
So to come back, I think that so it would be perfect here to use the Docker images. There are TeX Docker images from Paulo, or I don't know, one of the participants here, I love TeX. So they are producing regularly Docker images and pushing it to the Docker registry. So trying those two might be a good idea, and see how that works.
Mm-hmm. So one nice thing about this approach, when you actually, so the other question is, which you have when you set up this workflow, which you might have, is where do the PDFs go? Because you don't really want your collaborators to be cloning the PDFs every time they pull main.
No,
because that's extremely annoying. So, but on GitHub at least, you can get around that using essentially what they use to generate GitHub websites, right? GitHub pages. So you are free to push to any branch. So you can make a separate branch for this and automatically deploy just the PDF to that branch, which is also kind of useful.
Yes, and I use this actually for binary distribution. You can push force to it, so and drop the whole history, so that the whole Git repository does grow infinitely. The problem is with a big PDF, you use up a lot of space of binary, which Git is not very good at. And if you repeat this again and again and again a few thousand times, then it's getting heavy. But you can, so to say, deploy to a deployment or PDF branch and overwrite the history. That makes it very easy to keep the size of the repository small. Yes.
So the other thing which I could talk about for a few minutes is I did slightly gloss over the complexity required when you actually want to replace Jupyter, because you need to have a little bit of setup done in order to actually run these. But yeah, these are only very trivial, small examples which I have here. So, but yeah, I think we'll stop here if there are no further questions. And there are sources in the Zulip chat, and I'm always happy to.
I have a question for you. The continuous integration approach is, I think, good even for the non-technical collaborators. If you have someone who is a technician who maintains the continuous integration server, do you think it's possible to have such a setup if you don't have a computer scientist on the team, or is that a requirement?
You mean the initial setup?
I mean, just let's say a group of designers want to publish a book, and they decide they want to do it in TeX, and they want to use the continuous integration approach you propose. Would they be able to get the whole project up and running?
Yeah, that's an excellent question. So I've been thinking about this, and I think the easiest way, there are two approaches here. One, the slightly programming one, which you need a little bit of, you just need Python, is to make a cookie cutter template, because essentially you need to set up a few small variables like file name and a couple of things. And the rest of this is more or less the same across all of these. So, but I think the simplest approach for designers and other people would be to use the concept of a template repository. And I'm actually planning to set one up and see if some of my non-computer sciencey friends can actually use them. Because so a template repository on GitHub just allows you to make a copy of that repository and populate certain variables, and then it just gives you this configured repository with the CI. So yeah, that would be the approach there.
So at least some computer science affinity is needed to get it up and running. Like, I mean, some people would never dare editing a file and setting some variables, and they never have done it before.
Certainly,
so you would need someone to consult with if it doesn't work. Like a semicolon is missing here or there, and that kind of stuff, which can be very intimidating for a really novice user. If you set it up according to some video you have seen on YouTube that explains it, and you miss a colon or a semicolon or a dot someplace or an indentation in Python, and then it doesn't work, then you're lost usually. So in typical Windows environments, you get these wizards where you fill out forms and click through it, but that is not yet available here.
No, not for this.
And is it planned? Like a wizard setting up the project and the server, and then you say, okay, from now on you can use the server and have the continuous integration stuff, including Git and all that.
So
and would you do it still on a free? That means you say, in contrast to Overleaf, which is a commercial operation, they offer this support, but of course they need to be paid for it.
Those are all great questions from a usability point of view, but when I wrote this workflow, and what I was thinking about, especially with all my collaborators and all, is really a Git-based workflow. So the question is, does someone who is at that level of, who has that level of expertise which you're talking about, or lack thereof, will they be interested in a Git-based branching workflow in the first place, right? And if the answer is no, then it really becomes difficult to sort of have any benefits in this approach, right? If people want to work on a single branch and they don't need to maybe branch into different sections or work on different sections simultaneously, then there really isn't much of a use case for this. In that case, you should perhaps stick to, a single document with revisions, right?
Well, that's a good discussion point. I mean, in my experience with writing papers or so text files with Git, I use Git branches a lot for many billions of things, but for text documents, I haven't seen the need, mostly because changes are anyway localized to different paragraphs where people are working. And so in most of the cases, just merging works without any problem. So I'm not, I mean, why? Because branching would be required if you make a real big rework of a paper, right? Then that makes sense, right? You restructure it completely, move lots of stuff around. Then branching would be a good idea. But normal paper writing, okay, what in my experience of papers I have written, it's just people write and then people add comments here and stuff here and formulas here and fix the paragraph here. But this is easily done by merging and without the branching. So my experience, even working with 3 to 4 co-authors, is that branching hasn't been used that much. Most people just pull minus rebase and be happy with that.
That is an interesting thought. Okay, so I will definitely put more thought into making this more one-click for sure. And yeah, that's a great point. Excellent.
Thank you, Rohit. And if there are no more questions, I really wanted to support Norbert's point. I have met people and heard secondhand accounts of completely non-technical people who needed some kind of version control system, and both Git and before that Subversion were something that they could use very well in a very basic level, especially because in writing a paper, I haven't done so myself very often, but in writing a paper, you really wouldn't edit the same paragraph at the same time. So it's a very exciting, thank you for that. And if there's nothing more, we'll break here. The session will continue to run, and you are absolutely encouraged to go to Zulip or Topia to chat if you want, or have a breakfast or lunch or dinner or midnight stack, depending on your time zone. A midnight snack, not stack. And we'll see each other in 53 minutes.
Yeah, on